Dear students, today I am going to discuss the topics of flow through pipes part 2. This is the part of fluid mechanics and machinery under Mechanical Engineering Department, West Bengal State Council of Technical Education. At first, what is hydraulic gradient line and total energy gradient line? HGL, if we defined, it is defined as the line which gives the pressure head, that is P by W, and the datum head, that is the H, of the flowing fluid in a pipe with respect to some reference lines. In particular figure, what happened in this figure? There is a center line of the pipe, or from this below reference line, on the apart from this center line of the pipe, the red line, that is the HGL, that is the P by W, that is the pressure head, and from the reference line to the center line of the pipe, that is the H. So we can easily say that this is the summation of pressure head as well as datum head, that is the H. So the hydraulic gradient line lies one velocity head below the energy line. Total energy gradient line যাওয়ার আগে আমি এটা আরেকভাবে বলতে পারি, in the other words, it is a line which is obtained by joining the top of all vertical ordinates, that is the shown in this figure, that is the showing the pressure head P by W of a flowing fluid in a pipe from the central line of the pipe. Now the total energy gradient line. What is the total energy gradient line? If we defined, it is defined as the line which gives the sum of pressure head, that is the P by W, plus datum head, that is the H, and the velocity head, that is the V square upon 2G of a flowing fluid in a pipe with respect to some reference lines or datum line. For a fluid flow without any losses due to friction or components, that is the minor loss, the energy line would be at a constant level. In a practical world, the energy line decreases along the flow due to losses. Now a turbine in a flow reduces the energy line, and a pump or fan in the line increases the energy line. In the other words, we can say it is the line which is obtained by joining the top of all vertical ordinates, showing the sum of pressure head, that is the P by W, kinetic head V square upon 2G from the central line of the pipe. Now this is another topic, flow through pipe system. In particular diagram, pipes in series, that means অনেকগুলো পাইপ আমরা যদি পরপর কানেক্ট করে রাখি, তাহলে দ্যাট ইজ দ্য ইনফরমেশন অফ সিরিজ লাইন অফ দ্য পাইপ. So particular in this figure, pipes in series are pipes with different diameters and length connected together forming a pipeline. Consider pipes in series discharging water from a tank with higher water level to another with lower water level. এটা হচ্ছে অলওয়েজ দ্য ক্যারেক্টারিস্টিক্স অফ ওয়াটার। হাই লেভেল মানে অনেক উঁচু থেকে সবসময় জল কিন্তু নিচের দিকে ফ্লো হওয়ার প্রবণতা থাকে। তো অ্যাজ শোন দিস ফিগার, what happened, this is the on the left side high rise water tank, and on the bottom side there is the lower side water tank, and the particular the two tank in difference of HL height, that is the neglecting secondary that is the HL. Neglecting secondary losses, it is obvious that the total head loss HL between the two tanks is the sum of the friction losses through the pipeline. This is the if we friction losses through the pipeline are sum of the friction loss of each pipe, that is the HL equals to, we can easily write HF1 plus HF2 plus HF3. That is the HF equals to head loss due to friction one number pipe, that is the head loss due to the friction, that is the number of two pipeline, and HF3 that is the three number of pipeline, that is the HF3. So we can easily write HL equals to HF1 plus HF2 plus HF3. That is the Darcy-Weisbach equation. According to the Darcy-Weisbach equation, head loss due to friction, so in general form 4FL V square upon 2GD. Particular in pipe number 1, we can write HF1, that is the 4F1L1 V1 square by 2GD1. That means that is the different length and different diameter. So same things for pipe 2, that is the HF2 head loss due to the friction HF2. So we can easily write 4F2L2 V2 square by 2GD2. Same accordingly 4F3L3 V3 square by 2GD3. So or another way we can write 32F1L1 Q square, Q here the discharge of the water by pi square G d1 to the power 5 plus 32F2L2 Q2 square Q square by pi square G d2 the power 5 plus 32F3L3 Q square by pi square G d3 to the power 5. That is the pipes in series. Now come to the next topic, next point, that is the pipes in parallel. What happened? Parallel pipes means suppose একটা পাইপের সাথে আরেকটা পাইপ যদি আমরা পাশাপাশি রাখি, বা একটা রিজার্ভারের সাথে যদি আমরা অনেকগুলো পাইপকে অ্যাটাচ করি পাশাপাশি, then it is formed with that different diameters also and different lengths, then it form with the pipes in parallel. That means পাশাপাশি আমরা যদি রাখি তাহলে সেটা ফরমেশন হয় একটা পাইপ প্যারালাল পাইপসে। তো ইচ পাইপ ইজ কানেক্টেড separately to increase the discharge. Consider what happened. Consider pipes in parallel discharging water from a tank with higher water level to another with lower water level as shown this particular figure. Neglecting minor losses, it is obvious that the total head loss, that is the HL between the two tanks, is the same as the friction losses through each pipe. HL equals to HF1 equals to HF2, that is by L1 equals to L2 upon equals to L. That means that is the deep length equals to, that is the by mistakenly that is the same length, because that is the another on the left side there is the tanker, that is the tank number 1, and the below tanker that is the reservoir tanker or reservoir, that is the tank number 2. Particular tank number 1 connected to the tank number 2, all there is the fixed length, that is the fixed length and the different diameters. So we can easily write that is the L1 equals to L2 equals to L. So we can write HL equals to 4 F1L V1 square upon 2G D1 equals to 4 F2L V2 square upon 2G D2. So we can easily also write HL equals to 32 F1L, not L1, L Q1 square by pi square G D1 to the power 5 equals to 32 F2 L Q2 square. That is the different discharge. That is the different discharge because the different diameters. So 32 F2 L Q2 square by pi square G D to the power 5 D2 to the power 5. So we can write Q equals to, from the tank number 1, the discharge equals to Q, that is equals to Q1 plus Q2 particular on the different reservoir or tanker. So we can easily write Q equals to Q1 plus Q2. Now the last topics, power transmission through pipes. What happened? Power transmission. Power is transmitted through pipes by flowing water or other liquids flowing through them. What happened? The power transmitted depends upon, number 1, the weight of the liquid flowing through the pipe and the total head available at the end of the pipe. That is the two condition that is the power transmission happens. Consider a pipe, suppose AB is connected to a tank as shown this figure, below figure. The power available at the end of the pipe, that is the point B of the pipe, and the condition for maximum transmission of power will be obtained as mentioned below. So what happened? If now we consider a tank that is the already which a pipe AB is connected. Let us consider the following terms from figure. So L equals to length of the pipe, D equals to diameter of the pipe, capital H, that is the total head available at the inlet of pipe, V equals to velocity of flow in 5, that is now HF means head loss or loss of head due to friction, and F equals to coefficient of friction or frictional resistance. The head available at the outlet of the pipe, if minor loss we can neglected, then what happened? That is equals to total head at inlet minus loss of head due to friction, that is capital H minus small hf we can write. So H minus hf we can already say that 4FL V square y twice GD, that is the Darcy-Weisbach equation. So H minus 4FL V square y 2GD. Now weight of the water we can write, weight of the water, that is the the W, water flowing through pipe per second, that is the W equals to, we can write rho g into volume of water per second. So we can write rho g into area into velocity, that is rho g into pi by 4 in d square, that is the cross sectional area of the pipe, into velocity equals to V. So we can write rho g into pi by 4 d square into V. So the power transmitted at the outlet of the pipe, what happened, equals to weight of water per second into head at the outlet of the pipe, that is equals to rho g, already discussed, rho g into pi by 4 d square into V. Rho g in particular on the above equation, rho g into pi by 4 d square into V into H, capital H minus 4FL V square by 2GD, that is the watts. If we transmitted power transmitted if we expressed in kilowatt, what happened? Power transmitted at outlet of the pipe, that is equals to rho g upon 1000 into pi by 4 d square into V into capital H minus 4 FL V square by twice GD kilowatt. Now the efficiency of the power transmission, what happened? We can write what is the definition. Actually efficiency we have already known, it is the outlet by inlet. Here what happened? Power available at outlet of the pipe upon power supplied at the inlet of the pipe, that is equals to weight of water per second into head available at outlet by weight of water per second into head at inlet, that is equals to W into capital H minus small hf, that is the head loss due to friction, upon W into H equals to capital H minus small hf, that is the head, that is the total head available at the inlet of the pipe minus head loss due to friction hf by total head available at the inlet of the pipe. So it is the efficiency of the eta equals to H minus hf by capital A caps H. So next, the condition for maximum transmission of power. What happened? Maximum transmission of power, that is the dV into P, that is the dP by dV equals to 0. So dV equals to dV into rho g by 1000 into pi by 4 d square into HV minus 4 FL VQ by twice GD equals to 0. Rho g by 1000 into pi by 4 d square into H minus 4 into 3 into V FL V square by twice GD, that is equals to 0. H minus 3 into 4 FL V square by twice GD is equals to 0, or H minus 3 into HF equals to 0. So H equals to 3HF. So we can write HF equals to H upon 3. So আমরা easily লিখতে পারি power transmitted through a pipe will be maximum. So আমরা কনক্লুশন এইভাবে আসতে পারি যে পাওয়ার ট্রান্সমিটেড থ্রু এ পাইপ উইল বি ম্যাক্সিমাম হবে যখন কিনা না হেড লস ডিউ টু ফ্রিকশন উইল বি 1/3 অফ দ্য টোটাল হেড অ্যাট দ্য ইনলেট. সো হেড লস ডিউ টু ফ্রিকশন হবে কি টোটাল 1/3 অফ দ্য টোটাল হেড অ্যাভেলেবল অ্যাট দ্য ইনলেট. Maximum efficiency of transmission of power. So we can discuss the maximum efficiency of the transmission of the power. Efficiency of the power transmission through pipe is given by this equation eta equals to H capital H minus HF by H. So for maximum power transmission through pipe, the condition is already given in this particular field. HF equals to capital H by 3. So substituting this value of HF in efficiency, we get maximum eta equals to eta max H equals to H minus H by 3 by capital H. So 1 minus 1/3 equals to 2/3 or 66.7%. So we can easily say that the efficiency for maximum efficiency to get a power transmission or power transmitted, this is the 66.70%. Thank you and waiting for my next video.